Hi everyone, this is another skills video then, and we're introducing this idea of functions, which comes under C3. Now, we would have used the term function throughout your entire kind of mathematical career, but we've been using it incorrectly really, because it only applies to a specific case. So before we really go into functions and what it means, first I need to kind of show you what mappings are, which is a theoretical way of describing operations, and you don't need to be using these bubbles which you see on the board uh, at all, but I'm just going to use it to explain what's going on. Okay, so let's see. At the moment it will seem quite quick, quite easy, and then it will suddenly escalate in difficulty as normal, right? So what we've got here is I'm not going to use the word function, I'm going to use an operation, and the operation f says add 5 to everything. Okay, so what I've got is I've got this set of data and these squiggly brackets, that set notation. I've got a set of data -3, 1, 4, and 6. So a set of numbers. And this is like GCSE. I've got a machine and I'm going to insert these numbers into a machine, and then F is the machine itself. F takes the numbers in that machine and it will add 5 to them. So -3 will go to 2, 1 will go to 6, 4 will go to 9, and 6 will go to 11. So the important thing to notice or to realize is that everything in this bubble is the only things that F can work with. It's like a factory. In a factory, you can only produce with what parts you have. You can't produce something for which you don't have parts for. So what we have here, this bubble, a fancy word for the input, is called the domain. And what comes out is called the range. Now, before kind of graphs were used, this mapping system was a way to describe how to use operations, but the problem is you can't really see any patterns with it. And it wasn't until Descartes who said, and hence why it's called the Cartesian form. Cartesian means two variables, so this 2D approach. So this is our y and this is our x, right? And he said, well, I think it'd be better to represent it this way, and that way we can see patterns. So if I take x is -3, I get a corresponding y value of 2. If I have x is 1, I have a corresponding y value of 6. So I put a cross there. If I have 4, I get a corresponding y value of 9, and then I would get somewhere like that for 11. Now, I can't join these crosses together, can I? Because all I have to work with are these discrete, that's why it's called discrete data, these discrete numbers, these integers. All these numbers in between, by the way, there are an infinite number of them, between 1 and 4 alone, are not included in my function machine. If I want to join them together, I need to choose a variable x, and F will take x and add 5 to it, x plus 5, right? So the product will be f of x, because now our range, what is produced is the y value f of x, gives us x plus 5. So what is this x? Well, x, I'm saying, is any number then. Any number on this number line. So pi, e, irrational numbers, decimals, fractions, etc. This is the real numbers, okay? That's what this fancy R means. And this kind of weird looking E, that means element of the set. So you're saying x is within the set of all real numbers. So everything excluding imaginary numbers. And now I can join these crosses together. And therefore, here's our domain, because here's all the numbers that can go into our machine, and our range, our output, is f of x. Well, what possible numbers can the y value take? Well, you can see that this line is just going to keep going on forever, and therefore it covers every single number on this number line for the y. So therefore, if the domain covers all real numbers, the range covers all real numbers as well. Notice that this is a one-to-one relationship because one element in the domain goes to one element in the range. So one element, the domain, one to the range. Let's see how this compares to the next one. So here I've got another set, -2, -1, 1 and 2. This was our domain. Remember, our second bubble is the range. And the operation is square. So f takes -2 and it squares it to make 4. -1 to 1, 1 to 1, 2 goes to 4, right? Now notice the domain, if we were to graph this, is all of our x values. So it's important to have that in your mind. Domain means x values, and the range, the outcome, is our y values, right? If we were to represent this on a graph. Now, in our range, there are not 4 different numbers, there are only 2 different numbers. So there is another way that I could represent this, which will illustrate what kind of operation this is. So -2, 2, -1, 1, if I group them together like that, f happens to them, they're squared and they produce the same number 4, just like -1 and 1 square them produce the number 1. If I was to graph this at the moment, here's my domain x, here's my range y. I have -2, -1, 1, and 2. Here's 4 and 1, so cross, 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 cross. And again, I can't join them together because I haven't included every single number in between. So I'll put x and let's say -x for artistic license, and this will produce f of x. So now every single number that's included, and remember f of x is the same as x squared then, so f of x equals x squared. I've now included every number on that number line. So the domain of f is every single real number again, so every number of x is included. But this time the range, well, the range can be every real number, but let's look at the graph. This graph does not dip below the x-axis, does it? So it includes all the positive numbers and 0, but it doesn't include all of this area down here. So it's not every single number possible. It's every single number possible only above or equal to 0. Okay? And notice this is a many-to-one operation because many elements in the domain map to one element in the range. Many, so 1 and -1 from the domain go to 1 in the range. So this is a many-to-one. Now, what is a function then? So now we know what domains and ranges are. We can describe what a function actually is. Well, a function is a special operation or mapping. So let's say mapping, where each and every element in the domain maps to exactly one element in the range. Okay, so a special mapping where each and every element in the domain maps to exactly one element in the range. Let's go back to what we were doing before and let's see then whether we were dealing with functions or not. So we had domain and range for our first example. We had, say, 1, 2, x, blah, 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 and we had our f, which added 5 to them. So 6, 7, x plus 5. Does this meet the criteria? If I was to graph this, there's the graph there. Does this meet the criteria of a function? A one-to-one? Absolutely. Yes, it does. because one element in the range goes to exactly, sorry, one element in the domain goes to exactly one in the range. And if I was to do this graphically, you can see one element in the domain, so always the x stuff first, goes to one value of y. 1x returns one value of y. Secondly, we had our many to one, where we had our x squared stuff. So 1 minus 1 went to 4, 1, x minus x went to x squared. So again, is this a function? Absolutely. Absolutely. Because even though there are two things in the domain, each element in that domain still only goes to one value. Minus 2 does not return two values of y or three values of y. It only gives one value of y. So again, graphically, if I was to show that, domain first, so many in the domain, so these two x values equally apart, if it was say minus 2 and 2, give exactly the same y values. So many values in the x give 1 to the y, and therefore does fulfill this exactly one element uh, description. So if we then look at other things like what's called a one-to-many, well, let's think about that, where the operation is plus or minus square root, for example. So there's the domain in range. I've got 4, 9, and let's say x. Well, the square root of 4 plus or minus would be minus 2 and 2. The square root of 9 plus or minus would be 3 or minus 3. X would be square root of x minus square root of x. You see? If I was to draw this graphically, here's my graph. You could see then that one element in the domain, one x value, let's say 4, returned two values, many values, in the range. Okay, so I've got a one to many, and therefore this does not fulfill the exactly one element in the range criteria, does it? I do not have one value of y coming out of one value of the domain. Okay, so therefore this is not a function. So if a question ever asked, why is this not a function? You could say because it's a one-to-many operation. It's just an operation. It's not a function. Okay? And finally, you could have a scenario which could be described as a many-to-many. And that could be, for example, a circle. Because on a circle, you can see that many, let's say 2 and minus 2 again, many values in the domain, many x values, two x values, return two values of y. So again, we don't have this exactly one element in the range. So a many to many, I have two values of x giving two values of y. So therefore, this is not a function. All right? So basically, if it ends in 1, then it is a function. Because a many to one or a one to one is a function. If it ends in many, then it is not a function. Okay? Let's hammer that home a little bit more then with these pictures. So y equals 2 to the power of x. Here's your asymptote, which is y equals 0, right? What kind of graph is this? Well, let's do it. Let's go. So we've got one element of the x value gives one value of y. So therefore, this is a one-to-one. So it is a function. What's its range? What's its domain? Well, this thing will take any value of x, won't it? This will stretch to infinity, and this will stretch to infinity. So x will be all the reals for the domain. What about the range, though? Well, the range f of x, let's think about it. This can take all y values above the axes, but will it ever touch? No, because that's what this asymptote is for. So therefore, the range will be f of x is greater than 0, right? Number 2, this kind of quadratic thing. This thing is going to carry on all the way over here. What kind of thing is this? Well, if I go for the domain, Many values in the domain return one value, sorry, that one value here of y, right? So let's keep that again. Okay, so many values of x return the same value of y, right? So if that was -4 and say -2, that returns say -4 here, all right? So this is a many to one, which is a function, as we know. What's its domain? Well, the domain would be x again is all real numbers because this will stretch on for infinity this way and this way, right? But what about its, so right domain, what about its range? Well, f of x, look, this is its turning point, which hits at 2. You can see that all y values below 2 are covered, but anything above 2 is not covered, so therefore the range must be f of x is less than or equal to 2. Here we've got for number 3 a circle, which we know is a many to many, because we have many x value gives many y values. So it's not a function. And what's its domain? Because remember, even if it's not a function, it can still have a domain. Well, as it's a circle and it's centered at the origin, its x values can only be between 5 and -5. Its range, again, it's centered at 0 and its circle. Again, its y values can only be between 5 and -5. And number 4, finally, is this a function? And what kind of thing is it? Well, let's have a look. Many values of x give many values of y. This is a many to many. Okay. And what's its domain? So therefore it's not a function. What's its domain? What values of x can it take? Well, you can see that from here and here, all these values beyond a, including a, are included. And same here, less than or equal to -a are included, but anything in between is not included. The range, well, let's look at that. F of x. Can the y value be any number? Yeah, because look, 0 upwards to infinity, 0 downwards to infinity. Therefore, the range can be any real number. And there we go.